Good morning, dear students. Welcome back to physics class. Today, I would like to take the topics A. Multiplication of vectors by a real number and B. Addition of vectors. In last class, you learned about the definition, general notation, and important general characteristic of a vector. In your today class, I am going to teach you multiplication of vectors by real numbers. Let lambda be a positive number with which a vector A is to be multiplied. This multiplication gives a vector whose magnitude is changed by the factor lambda, but the direction is the same as that of A. This can be mathematically expressed as modulus of lambda vector A is equal to lambda into modulus of vector A if lambda is greater than 0. That is, lambda is a positive number. It is very important thing that you have to remember that how should take the magnitude of a vector. If you want to take magnitude of vector, you should take mod or modulus of that vector, which means its magnitude. Let A be a vector, then mod or modulus of vector A is its magnitude. Let me proceed. If vector A is multiplied by a positive real number 2, the resultant vector 2A has magnitude twice of the magnitude of the vector A. That is, its magnitude is 2 into magnitude of vector A. And also, the resultant vector is in the same direction as the vector A, which is shown in given figure. The figure shows multiplication of a vector by a positive number. Now, let me see through the subject how to produce result by multiplying a vector by a negative number. Let A be a vector which is going to multiply by a negative number minus lambda. The result is another vector whose direction is opposite to the direction of vector A and whose magnitude is lambda times the magnitude of the vector A. For example, multiplying a given vector A by negative numbers, say minus 1 and minus 1.5, gives vectors as shown in given figures. From this figure, you can see that the resultant vectors are in opposite directions to the direction of the vector A. The factor lambda by which a vector A is multiplied is a scalar or a scalar quantity having its own physical dimension or magnitude. So, the magnitude of lambda vector A is the product of the magnitudes of lambda and the vector A. For example, if you are going to multiply a constant velocity vector by duration or the time, you get displacement vector whose magnitude will be equal to the product of the magnitudes of the scalar quantity time and the constant velocity vector, which can be mathematically expressed as modulus of t vector v is equal to t into modulus of vector v, which is equal to modulus of vector s, which is the magnitude of the displacement vector s. Here I specified the magnitude of the result. You have to remember that the direction of the resultant vector S is the same direction as that of the velocity vector V, which is shown in given figure. On next, you are going to study about how to add two vectors each other. We can add one vector with another one. This vector addition always obeys the triangle law or equivalently the parallelogram law. I had pointed about this law in earlier class. Let us discuss on this. We shall describe this law of addition using the graphical method. Let us consider two vectors, vector A and vector B, that lie in a plane as shown in given figure. The length of the line segments representing these vectors are proportional to the magnitude of the vectors. To add the vector A with the vector B, you should shift the vector B parallel to itself towards the vector A and place this vector on the vector A in such a way that its tail is at the head of the vector A, which is shown in given figure. Then you have to join the tail of the vector A to the head of the vector B by this line OQ, which represents a vector R, that is the sum of the two vectors A and B. It is the resultant vector. This procedure of vector addition shows that vectors are arranged head to tail. So this graphical method is called the head to tail method. There is one question, why is also called head to tail method of vector addition as triangle method? As the two vectors and the resultant vector form three sides of a triangle, so this method is also known as triangle method of vector addition. Now you are going to study about the different properties of vector addition. First one is vector addition is commutative. If you are going to add the vector B with vector A, which is just the reverse process of addition of vector A with vector B, you get the same result. The resultant vector obtained has the same magnitude and direction as that of previous resultant vector. It is the vector R. Thus, vector addition is commutative, which can be mathematically expressed as vector A plus vector B is equal to vector B plus vector A. This commutative property of vector addition is represented graphically as shown in given figures 1 and 2. And second property of vector addition is that it also obeys the associative law. The addition of vectors obeys the associative law as illustrated in given figure. The result of adding the two vectors A and B first and then adding the third vector C is the same as the result of adding the two vectors B and C first and then adding the third vector A. The procedure of adding these vectors can be understandable by going through this diagram. This associative property of the vector addition can be mathematically expressed as vector A plus vector B plus vector C is equal to vector A plus vector B plus vector C. Can you think about what should be the result of adding two equal and opposite vectors? For this, consider two vectors, vector B and minus vector B, shown in given figure. When these two vectors are added, it gives vector B plus minus vector B. Since the magnitude of these two vectors are the same, but the directions are opposite, the resultant vector has zero magnitude and is represented by bold-faced number 0 called a null vector or a zero vector. That is, vector B minus vector B is equal to vector 0. Then magnitude of the null vector or zero vector is equal to modulus of vector 0 is equal to 0. Now you are going to study about what are the important properties of a null vector or a zero vector. Since the magnitude of a null vector is 0, its direction cannot be specified. The important properties of a null vector are: first one, the null vector results when you are going to multiply a vector A by the number 0. It is mathematically expressed as 0 into the vector A is equal to null vector. Second one is addition of any vector. Example, vector A with null vector results the same vector, that is the vector A. The mathematical expression is vector A plus null vector is equal to vector A. And third property is when any real number is multiplied with null vector, the result will be null vector. Its mathematical expression is lambda into null vector is equal to null vector. There is a question you need to answer now. What is the physical meaning of a zero vector? Consider the position and displacement vectors in a plane as shown in given figure. Now, suppose that an object which is at the point P at time t moves to the point P dash and then comes back to the point P. You can say that the displacement of the object will be equal to 0 because the initial and final positions of the object are coincided. So, it results to 0 displacement vector, which is a null vector. This example shows the physical meaning of a zero vector. Once again, you can check the natures of magnitudes and directions of the resultant vectors when vectors are multiplied with real numbers with help of the table given in this slide. In given table, in first column multiplication factor, in second column vector, in third column magnitude of vector after multiplication, and in fourth column direction of vector after the multiplication are given. In first case, if the multiplication factor is positive, that is, it is greater than 0, what should be the magnitude of the resultant vector? It will be lambda A. And what should be its direction? The direction of the resultant vector is same as that of vector A. In second case, if the multiplication factor is negative, that is, it is lower than 0, what should be the magnitude of the resultant vector? The resultant vector whose magnitude will be lambda a and its direction will be opposite to that of vector a. And in third case, if the multiplication factor is equal to 0, then the magnitude of the resultant vector will be equal to 0, that is, the resultant vector will be the null vector. And it has no direction because the initial and final positions are coincided. Students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.